So again, hello everyone, and thank you for joining us today for our chain inspection rigging training. My name is Gisela Clark, as I've said. I'm the social media specialist at Columbus McKinnon, and will be your host for today's webinar. Today's chain inspection training session is part one of a three-part rigging series. Today you'll learn the requirements of OSHA regulations and ASME guidelines for proper inspection of alloy chain slings. And we're so glad that you made it and can attend today. Presenting today will be Peter Cooke, our training manager specializing in rigging and load securement. Peter's dedicated 15 years to Columbus McKinnon as an engineer, designing lifts, slings, and forgings. He's traveled throughout the world teaching proper rigging techniques, rigging gear inspection, and hoisting crane inspection and maintenance. Also on the call today is Tim Lewis, our product manager for rigging products and manual hoists. A few quick points before we get started. As I said, we are recording the session today, and the recording link will be provided on our website, as well as being emailed to each of you in attendance today. So in case you have to step off the call and you don't want to miss something, you will have access to that recording. Everyone has been muted, so we encourage you to ask questions in the Q&A pane on the right-hand side of your page. If you look at the top corner, you'll see the little question mark. If you click on the question mark, the box will populate, and you can put in your question, and then we can address them. We will allow Peter to do the whole presentation and just take questions in the last 5 to 10 minutes. So again, thank you so much for your attention, and now I will turn the meeting over to Peter.
Okay, thank you all for attending. I do see somebody has a couple quick questions about they're supposed to hear something. There is a call-in number, so if you want to hear, you have to do the call-in number.
Yes, we already, I see. Yes,
so I just
for
want to
those of you, yes, I see that now. Thank you.
Oh, they're not going to be able to hear me, I guess, so they'll have to.
Yes, I'll tell you what, I'll go ahead and take that. I'll go ahead and take care of that. You can go ahead and get started.
All right, so before we begin, the information you're going to see here today is just for general information purposes only. It's not a substitute for views of applicable government regulations or standards. It should not be construed as legal advice or opinion from Columbus McKinnon, OSHA, or any of the presenters that are going to be talking today. Attendees with specific questions should refer to the site regulations or consult with attorneys. So we just want to make sure that's disclaimer that everybody realizes that. And the information here is copyrighted, like Gisela said. It is going to be posted on our website, so if you want to review it later, you're more than welcome to do so. But much of what we see in our presentations, we have permission from other organizations and entities and photos of people, their permission to reproduce. So we ask that you don't reproduce information without our written consent. Okay. And there's me, the presenter. I've been with CM for the last 16 years specializing in forgings, special forgings, designing engineered lifts, and now a full-time trainer teaching rigging and hoist inspection throughout the world. Some of the things we're going to cover today, we go to some of the definition of terms that we hear within our industry and within the standards. Understanding the difference between ASME and OSHA, that comes up a lot. Identifying the rigging gear, understanding which OSHA regulations or ASME standards apply, and general inspection and testing requirements per OSHA and ASME, as well as some of Columbus McKinnon standards. So some of the definition of terms, and these are important, and a lot of people get these mixed up and what they mean. So we'll kind of go through them and read here so that we know. Qualified person, a person who by possession of a recognized degree or certificate of professional standing, or who by extensive knowledge, training, and experience has successfully demonstrated the ability to solve or resolve problems relating to the subject matter at work. OSHA now, in their new construction standards, says qualified rigger, which is the same definition. Basically what they're saying is you have to be qualified for the rigging that you're performing. Designated person is the person selected or assigned by the employer or employee's representative as being qualified to perform specific duties. So inspection of chain slings, OSHA calls out a designated person, and they also will call out a competent person as one who is capable of identifying existing and predictable hazards in the surroundings or working conditions which are unsanitary, hazardous, or dangerous to employees, and who has authorization to take prompt corrective measures to eliminate them. And then we have the sling manufacturer, and you'll be hearing that in the presentation. and it is the person or company assembling or fabricating the sling components into their final form. The sling manufacturer and the manufacturer of the sling materials may or may not be identical. So we'll get into that a little too. So let's start out understanding the difference between ASME and OSHA. Okay, OSHA is started in 1971, and really what OSHA has for slings, for inspection of slings and usage of slings, is OSHA 1910.184, and that's what we refer to when we're doing sling inspections. There is no other document by OSHA for sling inspections, so that's the one we go by. It's free online. You can go to www.osha.gov, and you can print that out for yourself, absolutely free of charge from OSHA. And that's what is the law. When OSHA is missing a regulation for something, they have what's known as the general duty clause. Now, it has to be an imminent danger, a recognized hazard that someone's going to be injured for them to use the general duty clause. But they use the general duty clause, and they can piggyback on ASME, saying that there are regulations or standards out there, and so they will issue the general duty clause when they feel something has a danger and there's something written out there, a safety standard written out there already, that they can invoke the general duty clause. So that's kind of their loophole when they're missing information or regulations or law on something. Okay, so with that, OSHA is the law. ASME is a voluntary organization, but can be just as binding in the court of law, and OSHA, again, by using their general duty clause, can kind of use ASME standards to issue citations based on the general duty clause. So you want to hear the both. But I tell people ASME is more up to date than OSHA. We update our ASME regulations every 3 years. So if you're compliant with ASME, you're compliant with OSHA. And quickly to go over ASME from top to bottom, and this is a very good slide. If you're an inspector inspecting this type of equipment, or a user or a rigger, these are all the ASME regulations that you need to know. You can see 10 for monorails, 16 for overhead hoist underhung, then we get to 10 for hooks for a hoist, then for the slings, B9, and OSHA 1910-184. The below-the-hook lifting device is B20, back to 10 for hooks, 26 for rigging hardware if you got shackles or rings. Again, back to 9 for slings, 26 back to rigging hardware because we have a shackle in that picture, and then another below-the-hook lifting device. You can see there that there isn't much other than the slings that OSHA covers, so why they have to invoke their general duty clause when there is a serious violation for something. So, again, if you can stick with the ASME, I know they're voluntary, but you want to be compliant with ASME. If you're compliant with ASME, you're definitely compliant with OSHA. So what does 9 cover? It covers chain slings, wire rope, metal mesh slings, synthetic rope slings, synthetic web slings, and synthetic round slings. And then you refer to ASME B30.10 for the hooks. So you always go to this first standard, what the component is, and then inside the standard they'll reference you to the hooks and things of that nature. And then you go to that other standard for hook inspection and things like that. Today we're just going to cover basically what's in Chapter 1, chain slings. So before we begin, let's look at anatomy of a chain sling here and the components that make up. This is what would be a double DOS, double chain sling in its final form. And it would be with the ID, definitely has to need the ID tag, the ring, the body of the chain, mechanical coupling links could be welded or mechanical. The hook latch, we'll talk about that, and lower hook. And we always specify the tag should always be reach, which is bearing point to bearing point. A lot of people will specify by chain, and that's not correct. They'll say, I need 10 foot of chain or something. You always want to specify your slings by reach, and your tag should be specified by reach, and so don't get that wrong. You always want to identify your components to verify that the tag information is correct and that your tag is identifying the weakest link in the system. So every piece of reading hardware that you have should have some identifier on it. Master links need to identify the size and identify the manufacturer. So master links don't necessarily have a working load limit on it. They'll have the diameter of the link and then the manufacturer, but won't have the working load limit. So you have to be sure that that's the right link for the chain size. So you have to maybe look up that master link size. The chain needs the size, the grade, and the name of the manufacturer. We'll get into that. ID tag, present, legible, and correctly labeled. And it's up to we'll get into it, but it's up to the owner of the sling to maintain that. The hook needs identifier of the manufacturer, what grade it is, working load limit, and the correct latch for functioning. Now, we'll get into latches because that gets into a touchy subject. Here's the basic configurations for slings. You can have single, double, triple, and quad. And NACM, which is the National Association of Chain Manufacturers, we kind of adopted this type of nomenclature to identify slings. So the first letter is the number of legs. The second letter is the top fitting, which in this case is an oblong ring. And then the last letter is the type of hook or attachment that's on it, S being for sling hook. So if we had latch lock hooks, for example, are gaining a lot of popularity in the industry. So if these were all latch lock hooks, we would put an L at the end of it. And then some special configurations when you have an adjuster. You can have style A adjusters, style B adjusters, double basket type slings, and those have their own coding as well that we can, again, when we can abbreviate something, we can put it on the tag, and also when we do inspections, instead of writing it all out, we can abbreviate it, and that's the standard abbreviations that we use to identify chain slings. So it helps in the field. So let's start off with understanding grades of chain. And there are standard grades of chain, grades 30, 43, 70, 63, 88, and 100. And the grade strength equates to the strength level of chain. There's also a grade 120 out there, which I think there's only one manufacturer making it today, PWAG. Not a lot of attachments for it, so it's not real popular, or not a lot of it out there in the industry, but we should recognize there is a grade 120. But you have to identify your chain to be sure that it's the correct chain for rigging. The only chain we should be seeing for rigging, grade 63, which no manufacturer, I believe, is making anymore, just on special request, but there are some still old slings out there that were used for maintenance or even in the steel industry where they had 63 spec'd out for a long time. 63 is one of the first alloys that came out, so that is acceptable. We have grade 80 and grade 100, and then, of course, the grade 120 would also be acceptable. Those are the only grades of chain that you should be seeing for in your inspection purposes. If you see any other grade used on a sling, that sling should be immediately tagged out of service. Why the alloys? They contain additional steel alloy elements and result in their higher strength and enter the absorption properties, so they can take a lot of abuse. They have the ability to stretch 20% before rupture. Now, with that said, no amount of stretch is allowed, right? That is a designed safety within the alloy, right? So for let's say a 3/8 grade 80 chain to stretch, it almost takes 4 times or 5 times the work moment to get that to start to stretch a little bit. So the sling has been overloaded even if it's been stretched 2%, all right? So there's no amount of stretch allowed. So the minute you see stretch, you take it out of service. But what's nice about that, 20%, and that's per ASTM, by the way. They require that to be called an alloy chain. But it saves someone's life is what it's doing. Whereas compared to the carbon steel, they might get 3% to 7%. They just don't stretch like the alloy. We don't want to see that type of chain for slings. So here on this slide here, I don't know, Gisela, the writing isn't coming up, but we have a grade 63 that you see. G63 is the embossing. We have HA 800. That's what we call our grade 80 chain, and it's our branding, HA 800. And then we have HA 1000, which is the grade 100. CM brands it HA 800, HA 1000. That's kind of our brand logo for grade 80 and grade 100 chains, so that you know it's Columbus McKinnon chain. But really what we're looking for is a 10 or the 80s. That's what you're trying to find on the markings on the chain. When you look at working load limits on chain, just be aware that heat does affect it, and chain operates from, alloy chains, I should say, operate with a temperature of -40 degrees to 400 degrees Fahrenheit. When you exceed those temperatures, things start to change, so we do have heat charts. I'm not going to really get into this right now about as far as reductions, but we just want, what this slide is to show you is the prime working conditions for the chain is -40 to 400 degrees Fahrenheit. Anytime you're going to see any type of heat damage as an inspector, you're going to assume the worst and tag it out of service. OSHA says if chains reach a temperature of 1,000 degrees, even if it's a brand new sling and that sling reached 1,000 degrees, you have to throw it out. It's no longer good, and that's a requirement from OSHA. Mechanical coupling links, I said at the beginning that chains can be made from welded or mechanical coupling links. This is the type of mechanical link that you should be seeing, and it's only to connect chain to your fitting, all right? It shall not be used to connect two pieces of chain together. So if you wanted to make a 10-foot sling and, hey, I have two 5-foot pieces of chain, I'll just connect them together and I can make a sling, that is not allowed. So if you run across a sling where chain is being connected to make it longer, that's not acceptable per ASME or the manufacturers, so we don't want to see that as well. And the interesting thing here is, prior initial use, all new and repaired chain and components of an alloy steel chain sling, either individually or as assembly, shall be proof tested by the sling manufacturer or a qualified person. So what that means is you can assemble your own slings. These mechanical couplings are safe to use. They have been tested. So if you assemble your own sling, you do not have to be performing a load test. With that said, there was an interpretation going around a few years ago where someone was changing up hooks. A hook went bad on the sling, and so they basically just brought in a new hook and the same type of hook, connected it to the sling with the appropriate hammer lock or mechanical coupling link. And the question was, even there was an OSHA citation, hey, you can't do that. You have to load test the sling after that, and that was wrong. You do not have to reload test it because the hook has already been tested and the mechanical coupling link has been tested. And prior to that, all the rest of the components have been tested. So if there's nothing wrong with the sling, you don't have to do another load test. Okay, so that's a big one, and that comes up a lot. Things you shouldn't see for mechanical coupling links, mid links, quick links, connection links, lap links, cold shunts. None of those should be used. You run across any of those and deem that out of service immediately. Those again weren't meant for overhead lifting. They're not even load tested. I mean, we might batch test them. I think most manufacturers just kind of batch test them here and there. But they're not alloy, and they're not meant for overhead lifting. The chart here shows some of the other manufacturers and what they do for their embossing. And again, just kind of look over where the alloy part of it is. And really what we're looking for are the 10s and the 8s. So again, CM has HA800, HA1000 for their grade 80, grade 100. If you go to ACO, they use A8A, A10, Cooper Campbell, C8, C10. Crosby uses CG8. Don't get so caught up in the nomenclature before it. To CG, that stands for Crosby Group. C stands for Campbell. A for that stands for ACO, so it's ACO 80 alloy. And our HA stands for Herculoy, which is our trade name. So you're looking for the 8s and the 10s, and so a lot of people get confused by everything before it, and it's basically branding. McLeod uses an 8 or an L. L8 they could use. Peerless Chain. P8, P10, and then we have some of the foreign competition coming in, and they use, PWAG, PW, A80. And some of this may have changed. We put this together. So if anyone if anything from this chart has changed, feel free to email me and say, hey, this has changed, or if anyone is very familiar with the other chain manufacturers, when we do inspection training, we want to train on all manufacturers and how to inspect so that we can identify slings properly. Sling tags, let's start when you're doing the inspection. So after you identify everything that it's correct, and now you want to look at the tag, you want to make sure the tag is correct. And what per OSHA and ASME, what you need on there is the rated load and the angle, if it's a multiple leg sling, and the angle in which it's going to be used at, the reach, the size, the chain grade, who the manufacturer of the chain is, the type, and the serial number. The manufacturer of the chain will be about who the manufacturer of the sling is, okay? Again, the manufacturer of the sling may not be the same as the manufacturer of the components, right? If you buy all mechanical links and chain components and assemble the sling yourself, you become the sling manufacturer, right? And there's nothing wrong with that. You have assembled the sling in its final form, and now you're the sling manufacturer. So you would have to put your company logo or initials on that tag to identify you as the sling manufacturer. Even if the tag were to fall off and you lost the tag, you want to go and re-tag that sling. Now, if you're trained properly and qualified to do so, you could do that. However, you would have to put you as the sling man, even though you didn't make the entire sling up, by putting the new tag on makes you the sling manufacturer because you're putting the sling in its final form. A sling with a tag is a sling in its final form. Again, no further load testing will be required if you're not, it's all mechanical links, no further load testing is required. Same with a welded assembly. Only certified stations are, per the manufacturers, can make welded assemblies, and they're certified to do so, and those have been tested prior to going in service. So even if you're inspecting a sling with a welded assembly, that sling has been tested for you, so you would no longer have to do that test. But if we repaired a sling and did any type of welding on a coupler, which are only certain places can do that per the manufacturers of chain, they have to test your slings. So here's a sling here, and let's see what that tag should read. And if this was a 3/8 chain sling, we would go here and look at a chain chart, and let's say the tag, we want to identify the tag information. And oops, sorry about that. We would look, it's a 3/8 grade. Let's say if it's a grade, let's just for this purpose, let's say it's a grade 80. That's what we identified. It's 3/8 chain. And it's a double sling. In this case, we would go across on our charts, find the double 2-leg rating, and go down, and we would see that 3/8 grade 80 is good for 12,300 pounds. We want to make sure that all the components in that sling are capable of holding 12,300 pounds. Now, the hooks, eventually you're going to, so really, in reality here, the 3/8 chain is good for 7,100, so each branch would have to hold 7,100 pounds at a minimum, but the entire sling used in assembly would be rated at 12,300 pounds, so the top link would have to take 12,300 pounds, okay? And we would stamp that at a 60-degree angle. So here's the tag. So in this case, this tag reads CM Percoloy 800, so we know it's a grade 80. We looked at the chain. Yep, that's right. That's what it is. It has a serial number on it. Great. That's what OSHA requires. That's what ASME requires. And then it says 3/8 by 10 foot. That would be the reach. We want to verify that. Is that truly the reach? And make sure it's not something different. If it is, then either somebody tagged it wrong or the sling has been altered. In this case, it says WLL, which is the working load limit, from 60 degrees from the horizontal. That's the angle at which, the optimum angle that it can be used at. So it's good for 12,300 pounds in branches too. Now, if a rigger were to use this at a 45 or the 30-degree angle, they would have to refer to rigging charts or a rigging pocket guide and derate their chain accordingly according to the chart. But we can tag it with most people. There's no written rule that says you have to tag it at a 60-degree angle, but most sling manufacturers will tag a sling at a 60-degree angle if it's a multiple-leg sling. Okay, and there's more on that. We just released a blog where there's more information on that. And then just for all intents and purposes, here's grade 100. And again, if that was a grade 100, we would rate that at 15.2. Now, be careful. I've seen a lot of slings out there where it has grade 100 chain and grade 80 hooks. So, again, it's important to identify the grade of everything. What's the grade of hooks? What's the grade of chain? And that happens. Let's say Campbell Chain put grade 100 chain on sale. They had a big promotion. And then CM put grade 80 hooks on sale, and they had a great promotion. Well, the rigging house may buy both and combine those two in the sling. There's nothing wrong with doing that. They can combine grade 80 and grade 100 together. It's not ideal, but it can be done. There's no rule that says you can't do it. You just have to tag the sling with the weakest component. So in that case, the sling would have to be tagged to grade 80, even though it had grade 100 chain. So again, it's important to match the components up and be sure that you're tagging with the weakest component in the system. So identification of links and rings, again, we talked about this, but manufacturer, rated load or size, you may not have the rated load. It might be just the size, the diameter. You'll have to look it up. And the grade to identify it, what grade of links. There's grade 80, grade 100 links out there. CM is now branding them, dual grading them, grade 100, grade 80 links. That will be coming out in the near future, and there's other manufacturers that have done that already as well. But still, the old stuff is still out there, the grade 80s and grade 100s, so you want to be sure you identify it properly. Okay, so that's identification. So let's get into a little bit of inspection. So we got to do a link-by-link inspection, and we're looking for anything abnormal, twists, bends, nicks, gouges, excessive wear, stretch. We talked about stretch, so any form of stretch is unacceptable. And basically, if you're seeing something and you're hemming and hawing about it, chances are you're going to have to deem it out of service, okay? If the chain is painted and you can't see the steel, so it maybe have been used in the paint booth or a painting environment, you can't inspect it. Until that paint is removed, you can't inspect it. If it's a lot of gunk, oil, dirt, grit, grease, and you really can't inspect it, grease and gunk can fill in nicks and gouges that you would never catch in inspection. It's important to clean your chains. How do you clean them? Well, the repair stations and we're certified inspection station people that do this for a living. They have what's known as tumblers, and they tumble it with walnut shells, newspaper, leather, and they'll tumble the chains. And I'm always amazed when I ran the Sling station in Tonawanda, New York, for CM. I always couldn't believe how, some of the chains would come in. I'm like, they'll never get clean, and then they were tumbled, and when they come out, they look better than when they were brand new, and they just and everything jumps out at you. Once you tumble them, you can see every abnormality or anything like it. Everything just jumps out at you. So we do recommend when things are really bad and very dirty that you get them tumbled properly so that you can inspect it properly. If you can't see it, you can't inspect it. So a thorough periodic inspection of a chain sling should be free of foreign matter. A dirty sling can hide anomalies. B9 says performed by a designated person. OSHA will say a competent person. Really, you can chase your tail here, competent, designated, qualified, and go round and round. Really what it comes down to is proper training and experience, that you're just competent to do it, that you know what you're doing, you know what you're looking for. At least once a year, a written record needs to have been done on the sling, and that you did it, write the serial number down, either everything was great, checked out, or it needs to come out of service. So you have to have a written record. More so if you may have to step that up in some environments, so that might have to be done quarterly, might have to be done twice a year. So do that. So why do we do inspections? Again, minimum once a year, but the real reason is to gain knowledge in the frequency of use. Again, we may have to step it up. The severity conditions the chain is subject to, the nature of lifts being made, and the gain knowledge or experience. What I can tell is if I'm going on an inspection and they're using the slings, and a rigger is using the slings, and they're in bad condition, so bad that even if it's a rejectable sling and the rigger is using it, that tells me that the rigger needs to be trained, that they don't know what they're doing. It is the rigger's responsibility to inspect that equipment before they use it. And that's for any sling. So if I was an OSHA inspector, and again, on the construction site, and I wanted to see if a rigger was qualified, before I even talk to anybody, I would like to look at their rigging gear, and if I found rigging equipment, slings, or anything that were rejectable, that tells me the rigger doesn't know what they're doing, all right? Because that's part of the training of a qualified rigger is to identify, even a basic rigger, is to identify bad equipment and not use it. So that's where I would start. But then again, as an inspector, you may want to point things out. Why are these things happening? Why is it in such bad condition? It may be lack of training. It may be the wrong sling for the job. They might need something else. It's just not right. They might have to figure something else out for them. So a good inspector not only doesn't just do the inspection, they kind of give some pointers as well. Here, why are we seeing this? Okay? So what are we looking for in the chain? Wear, deformation, twist, stretch, sharp, turn, reverse, mix of gouges, abrasion, corrosion, heat damage, and look at the attachments. So here's some pictures of chain bent, even if it's one link, right? We're moving out of service. So, again, you're only as good as the weakest link in your system. So if we have one damaged link, it's coming out. Stretched, inner link wear. Rotate it. Look at those inner links, right? That you might not see it when it's out. So rotate the link a little bit. Heat damage. This is pretty severe in this picture, but a dot of weld splatter, to me, I would reject it. I don't know what happened. I don't know how hot that weld splatter is. It could make for a weak area on that chain. So I would reject it. I always get the question, what's a nick, gouge, what's a scratch, and what's considered a nick or a gouge, and that's always a tough one. My rule of thumb, and in my opinion, again, there's no rule written for this, what's a nick, gouge, scratch, things of that nature. If I can get my fingernail in it, to me, that's a nick or a gouge. Now, again, if I'm hemming and hawing about it and I'm undecisive, I'm always going to weigh on the conservative side and reject that chain. Because there's really nothing to tell me. It's my call as an inspector whether I want to say it's okay or it's not okay. So if I'm inspecting, if I can get my fingernail in there, that to me is enough, and I would reject it. Not, a lot of this stuff tells me the riggers didn't know what they were doing, so if they're using slings like this, here's bolts in a sling that they were using to adjust. Instead of using a grab hook, they were shortening links by throwing bolts in, and they were shearing and shooting out everywhere. I had to do a call there and try to figure out something for them. Gouges, homemade type of equipment, and then low carbon link connections, not a good thing. Corrosion, I mean, you're going to get a general, steel is steel, right, and if it's not lubricated, it's going to start to get a general surface rust. That's okay, but when you get these deep pits like this, when you oil it up and you're still seeing some, that can be considered a nick or a gouge, so I would remove it from service. This is pretty bad in this picture. Again, deformation, weld damage, here's some severe heat damage. Remove from service. Wear criteria, you saw that picture of wear. All the manufacturers of chain have a standard wear criteria for the NACM. And by the way, all the strength levels of chain are equal per the NACM, so whether you buy grade 80 chain from any of the chain manufacturers in the United States, the working load limits are all the same, right? We do not differ in working load limits. As a chain organization called the National Association of Chain Manufacturers, we've all agreed a long time ago that we wouldn't play that game of, hey, ours is a little bit better working load limit than yours. We aren't going to play that game. We come out and say, hey, they're all the same working load limits, okay? Now, each adds their own little recipe, like I said, making chocolate chip cookies. If we all made chocolate chip cookies, everyone, hey, I might add a little bit more chocolate in mine. Someone may add a little bit more sugar. So all they do, they play with the formula, get better properties here and there, and so they are a little bit different as far as, what they say, what they like best. And they like their own recipe better. We like our recipe, but in the end, they're all the same work limit. They all have to stretch 20%, and the rejection criteria is the same. All right. Links and rings, again, a link is just like a piece of chain, so we're going to look at it the same way, looking for stretch. 10% wear for links and rings. You can always find a good area and compare it and have 10% wear, but the same criteria for rejection. Again, you can see a weld splatter there, more than weld splatter, just a lot of heat damage there. Stretch, wear, nicks, gouges, those are things we would take out of service as far as upper links are concerned. Hooks, again, any deformation, the throat opening is 5% to a quarter inch. On the small hooks, you're going to see the 5%. On the large hooks, you're going to see a quarter inch. And then we have that little note, or it's recommended by the sling manufacturer. So the sling manufacturer could have a different criteria, and we're allowed to do that. And this is per ASME.10, by the way. Inoperative latch. All right, any latch that does not close the hook or throat opening. Okay, so if it's a wrong latch or someone's, it's busted or you want to get that repaired. Anywhere exceeding 10% in the saddle. Look for grinding, people grinding on hooks or trying to do something with them, welding them. I actually had a guy weld splatter his initials with the welding stick, put his initials on there. That was his hook. Well, he just put himself in danger. And the markings, which needs the manufacturer logo or trademark. Typically, chain hooks will have the chain size on there. It'll say 3/8 in the grade and the manufacturer. It won't have the working limit. It'll correlate to the chain size. So if it's 3/8 grade 100, it goes with 3/8 chain, but it won't give the working limit. That's acceptable. Now, the big old question, latches. Get this all the time. Are latches required on chain slings? Okay, here's the deal. ASME B10 does not address latches. You have to go to the standards, ASME B9. So we go there, we look in there. ASME B9 does not make it mandatory for latches. Neither does OSHA 1910.184. There are no statements in there that says you shall have a latch, other than the fact that if the latch is damaged or inoperable, it should be replaced. Okay? It's kind of an all or nothing thing. So if I had a 4-legged chain sling and 3 of the legs had a latch and 1 was missing, all right, that's a damaged latch. One went missing, so giving the standards, that's a rejectable criteria. Now, if I had no latches on that same chain sling, I can't reject it because it's not required. There is, and again, read the OSHA standards. Nothing says that you must have it. There is actually a letter of interpretation in there that addresses that as well, where I believe it was a gentleman from Sling that asked OSHA, and they come back and said, no, we don't have that requirement, and then they, in true OSHA fashion, say, but it is a way to make sure that the hook remains secured to the load in a flat condition, but it's not required. Hoisting equipment, lever tools, things of that nature, that's a different story. Right in the B16 and the B21 standard, it'll say you shall have a latch on that equipment. It'll say it right in there. The Sling standards don't say that, okay? Then I'll get the question is, well, if it has a provision for a latch, then it also, well, it's not written that way, okay? So we can't interpret the law to our liking. If it's not there, if it's not stated, it's not law. It's not an ASME, and it's not B10. However, we do recommend you put latches on there. Latches are a great way to see if something was wrong. So if it was sprung, it draws attention to the rigger that maybe that it's been pulled open. It draws attention to the inspector. And it's, again, while you're rigging and you're attaching to the load, it helps keep those hooks secured onto the load so that when you go to lift, you're not going to tip load or anything like that, the hook didn't slip out and you weren't aware of it. So those are all good reasons to have a latch. But again, they're not required. And then again, there's a letter of interpretation in OSHA. You can look it up in OSHA. Get that question all the time, and if I had $5 for every time I had to write a letter, I'd be retired right now. Okay, so that was a quick overview of chain sling inspections. This session has been recorded. I know I went a lot of information for you there. At a fast pace because these are short sessions. We do have training courses available where we go in great detail. We inspect many slings. You're tested, and that's our rigging gear inspection course. We have some other seminars coming up here May 22nd. We're going to talk about shackle inspection and the proper use of shackles. June 6th, rigging with lever tools. So that's another informational seminar we're going to come up with and do for you guys, just like this session. And then if the full-blown sessions, a qualified rigger workshop, which includes rigging gear inspection, basic rigger, advanced rigger, and we have it at our hands-on training facility in Tonawanda, New York. We have 2 3-ton overhead crane systems, lift a variety of loads. It's a really great training course, very hands-on, and we get great reviews from it. People love it coming there. We also do rigging gear inspection courses. We have one in Chicago on June 18th. Columbus, Ohio, June 23rd, August 6th, back here in Tonawanda, and then again the qualified rigging course, which also contains the rigging gear inspection course 6th through the 8th of August. But again, we go in detail, not just chain either. It's all rigging gear. So we would go through wire rope, metal mesh, synthetic slings, shackles, lever tools, manual hoists. So it's a full day as far as just the rigging gear inspection goes, inspecting equipment and hands-on and getting tested on it hands-on. We'll have a test where you actually have to go and find bad equipment within a group of 20 equipment. So that's all done at our facilities in Tonawanda, Columbus, Ohio, and Chicago. You can go and do the qualified rigger course here at our hands-on facility because we have to have hands-on to do that.
Peter, we have gotten a question.
Sure.
I wanted to address, and this came in from Mike. His question was, which grade is star grade? Is it 80 or 100?
That would be neither. Star grade chain is made specifically for a hoist, and that's an excellent question, by the way. And I didn't touch on it. As far as star grade chain is made for electric chain hoist. It's a CM. It's made for Columbus McKinnon hoist, and it's very different from alloy chains. It's not a grade A, grade 100. It's our own hoist that we manufacture. It definitely has the strength level beyond, even equal to or beyond a grade A, grade 100, but does not have the same properties. Because the chain is going over a fast speed of the lift wheel, it's very hard. We need to have that, where alloy chain is not, right? We can't have it very hard because we wouldn't get that 20% stretch. Also, the hoist chain does not stretch. We can't, right? If we made it, will about 3%. but that's about it. But we could design a hoist that would take to the alloy chain, but we don't want to because we would have jammed up hoist everywhere. If the chain stretched, the hoist would get jammed up. Hoist chain, the star grade, which is for CM electric hoist only, should never come in contact with the load, should never be used for slings, okay? If someone is rigging with hoist chain and wrapping it around something, they're putting themselves in great danger. The thinking is, well, a hoist does overhead lifting, I could probably use it for a sling. No, you cannot. It is not the same animal. It is to run in a straight line into the hoist and back and never to come in contact with anything. And that's for any hoist manufacturer, by the way, whatever grades of chain. I know there's a hoist manufacturer that has, they say, grade 100 chain in their hoist. Do not get that confused. What they are saying is it has the strength level of a grade 100, but it is not a grade 100 alloy sling chain. It's very different. It can't stretch 20%. It doesn't have that toughness, abrasion resistance. It just cannot be used for rigging, so don't get that confused. All they're saying is it has the strength level of a grade 100. And that kind of, I wish they wouldn't do that because people get confused that maybe it can be used for slings and it can't, okay? So, but, and it's good chain, it just don't use it for rigging. Hopefully I answered your question properly there. We also have disc grade chain, which is a dot on the chain, and that's used in our manual products, all right? So you got to know the difference. What you're looking for slings are the Herc alloy 800, 1000, or the 80s and the 10s from, as you've seen from the other chain manufacturers. That's what you're looking for, but never use chain from a hoist for rigging. Only for lifting into, using it into the hoist.
Okay, Peter, we have just a few more minutes before we need to wrap up, and we have 3 more questions.
Okay.
What is the largest bar diameter available for chain slings?
As far as size, the grade 80, we go up to 1.25 inch chain. And as far as CM is concerned, I believe we're up to 5/8 chain. Up to 3/4, and some may go higher, but you'd have to look by the manufacturer as far as the grade 100 is concerned, what they go up to, but they do not go up to higher than that. 1.25 inch alloy is the largest that's out there.
Okay. And why can't a hammerlock be used to connect 2 chains together?
Number one, it can create a snagging hazard. There is a little bit of a lip on hammerlock, so it can create a snagging hazard and cause a shock load. 2, if it's articulated in the wrong direction, it can only hinge in one direction, so it could compromise the hammerlock. Now, a lot of people have the argument, well, the way I'm using it, it's never going to be compromised. We get that. However, you just can't say, well, in these circumstances, it's either an all or nothing thing. So, as a committee for ASME B39, which has all the chain manufacturers represented, we came up with that ruling that say, no, we just don't want you to use hammerlocks in that manner. It's just an unsafe practice to do it. It could lead someone to think that they're doing it okay, and they're not, and so it could compromise the link by having it in the body of a sling.
Okay, we have 2 more questions, and feel free to go ahead and type more questions. We won't be able to take any more after those 2, but Peter will contact you and gladly answer them via email within the next day. So the next question is, if we pull test a chain sling and it has a legible tag, can we simply put an inspection tag with the new inspection tag on the old tag?
Repeat that one more time, Gisela.
Okay, if we pull test a chain sling and it has a legible tag, can we simply put an inspection tag with the new inspection tag on the old tag?
If they're keeping the old, if they're keeping the old tag, the answer is yes, they could. If they're going to remove the tag, okay, and put their own tag on there, that's considered a repair, okay. So therefore, you become the sling manufacturer if you're taking the old tag off, and you would have to put your company identifier on that tag.
Okay.
Okay.
And yes, and it's funny, you just wrote a blog post about that.
Yeah, it just came out today. It's from cmcolive.com.
In fact, Peter, go to the last slide just so they can see how to connect to the blog. But okay, one last question that came in. Just a second. Gunnable chain has a blue coating on the chain now. If that coating has a gouge or nick, should that chain be rejected?
If the coating, no. If it's just the coating and the steel isn't damaged, no, absolutely not. It's just a coating that Gunnable is putting on there as far as for environmental purposes to prevent the chain from rusting. So, however, I think what they're asking is, does the paint need to be removed for inspection? And the answer is no, because that paint was put on there brand new, and if there's going to be a nick or a gouge, that paint's going to get chipped off, so you're going to be able to see it. It's the paint after the fact, after manufacture. It's the paint from a paint booth, the gunk and things like that, that you can't see. The coatings that they put on the slings aren't that thick anyway. That it would compromise. What I'm talking about is just a real thick gunk that you can't see anything. The paint on the paint on the Gunnable chain is not going to compromise from you not finding a nick or a gouge because it's done prior in brand new condition. And so therefore, if it did arise, you would see it.
Okay, that is.
I hope I answered that correctly the way they wanted that answered. If that's what they were asking.
Okay. All right. Really quick, before we wrap up, we've got a few polling questions. The first one is, were you aware before today that Columbus McKinnon offered a 3-day qualified rigger workshop and rigging gear inspection training? I know a good portion of you have answered. We'll just give it a couple more seconds for the remainder of you to do it. And then we'll switch. We'd just like to get this feedback. Thank you very much for voting. All right. And I will close that one now. A couple more seconds. But as I said, while that poll is closing and the new one is opening, you can go to our blog. On this page, you can see it. It's at blog.cmworks.com. You can get there by going to our website at cmworks.com and just click on the blog. And the other thing we have another polling question, which is, how did you hear about this webinar? Was it through email communication? Let me open it. Email communication, Facebook, LinkedIn, Twitter. I saw a couple of you from Twitter on the call, which always gets me excited because I love Twitter. My distributor, you heard it through one of your distributors, or your CMCO representative. Like I said, we love to get feedback so we know what the best ways of communicating with you are. And for those of you that have answered that question, you can also connect with us on Twitter. Like I said, that's one of my, I love Twitter, at CMCO Live or at CM Entertainment. We also, by the way, on our blog, we have over 100 technical articles. As we said today, we posted one on sling tag inspections, and Peter just wrote that this week. It's a great article. You want to check it out. We also are on Facebook. Find us at Columbus McKinnon. Let me see. And we're going to jump to the third poll. Quick. Okay. And you can also find us on YouTube. We have many, many videos, which I've been sharing recently on Twitter and on Facebook, and a lot of great how-tos and great information about training and our products, how they're used, where they're used. And we're also on LinkedIn. We have a company page on LinkedIn where you can follow a lot of our company updates. And last but not least, you can also find us on Google+. We're really trying to grow our Google+ followers and following. So please connect with us there if you're involved with that, or encourage your companies to. We'd love to really embrace that. It's a great new tool that's growing, and we'd like to engage with as many of you as possible. So on that point, if you could vote on, like I said, the last poll. We want to thank you for coming today. Thank you for participating. Any final questions that were typed in, we will definitely address in the next 24 hours. You'll get an email. And I know several of you have asked whether you'd have access to the recording. We will be sending a follow-up thank you email to everyone who attended today, registered and attended, and you will receive a link to the recorded webinar. So on that point, we'd like to just thank you again for participating, for taking your time, and wish you a good week. And if you have any questions after the fact, Peter, can you just go back to your slide? I believe it is, what is it? Slide 8. So they can send you an email if they would like to. I'm sorry, slide 9. that will give everyone your email address should they have any questions after the fact.
Yeah, peter.cooke@cmworks.com, and Cooke with an E at the end.
Very good.
A lot of people call me Cookie, but that's okay.
Thank you again, everyone, and we wish you a great week.